Are you back? Cool. Let's actually do the block controller side of this. So I'm going to go back to my page, and when you want to edit your blocks, you go to this little pencil right here. It's either a pencil or a magic wand. I'm not sure which one. They're both applicable. Whether it's magic or whether you're writing things down, you get to create things, right? So let's click on that. The block controller editor page here, this control panel. This feels a lot like Q-SYS Designer does, where you've got a big white space and you can arrange things in that space however you want. And on the side of that space, you have a panel full of things that you can grab and add into it. We're going to go through each of these categories. You'll see all of these blocks by the end of this course. Right now, let's just take a quick overview of them. If you click on the Values tab, these are various ways of applying different values, whether that is a number, whether it's a true-false state, something like that. If I go to strings, these are various ways of creating strings. That's just a sequence of characters, or text as you may call it. We can add it, we can build it, we can look within one and pull out and search for different things within a string of text. We'll use a lot of these throughout the class. Arrays are essentially tables of information. We'll use these later on. Operators are where you'll go when you need to perform some sort of function onto your values or compare them. So the green ones will let you do something, like I can add them, I can multiply them, I can divide them. The yellow ones down here are more logic comparators. I can check to see if two things are equal. I can use an AND block to say, hey, both of these things are going to be used in this next function, things like that. Flow control. We'll use this all the time. This very first block you will use in every single script you ever write. This is the if-else block, where you say, hey, if one thing is true, I'm going to perform this list of activities. If something else is true, I'm going to perform this other list of activities. That is extremely useful. These next three blocks are loops, and we'll talk about those later near the end of class as well. The System tab, this has all the various things that could be useful to your Q-SYS system. Things like this one here, which I mentioned earlier, the showing different layers on your UCI option. The one where you can debug a message to your block controller's debug window. You can log errors and log messages. You can write Lua code. You can write comments. We'll use these all the time. Variables and functions, we're going to get deep into these too. Variables let you basically save information. It's something that can be anything. You can change what it is, but reference the object by its name, regardless of what value it's holding. And then a function is a list of commands or activities that the script will perform that also has a name. And then you can recall that function just by calling out its name, rather than making it execute every single line every single time you want it to do something. We got timers as well. Timers allow you to do things that you would expect timers to do, right? You can have something occur after a certain amount of time has passed, or reliably as a timer starts and then or ends and then starts again. Those are all of your main blocks. You've also got some blocks for controls that are specific to the controls you have added within this block controller. You can see already we got nav1, room, nav2, displays, nav3, cameras, or we can even select any control if we want any of those. Now, before we start snapping these blocks together, let's actually get a little reminder of all the ways that they connect. Just as a reminder, you should be familiar with this from the Control 101 videos, but let's just take a look real quick. There's generally three types of blocks in here. One of them, for instance, if I go to my system and I grab this on touchscreen, set screen on. This is a real good example of a basic code block. You can see it's got teeth at the top and teeth at the bottom. What this block does is it resolves the entirety of its code, and then it follows the little arrow down, and it moves on to the next block, and then that block resolves all of its code. So these codes operate in sequence, one above the other, above the other. So you can see that because it has teeth above and below, it could be connected in any sequence of vertical blocks. Another type of block is the event handler block. I'm going to grab one for a function. Here's a function that you can see it starts the line of code. It's got this large crocodile mouth sort of looking thing, and you can see that that first arrow points down so that if there is a line of code in there, it will resolve that line of code and then move down. And in this case, you can see it gives us this nice big flat bottom, which tells us that's the end of that particular line of code. Generally speaking, you're kind of trying to build blocks that will always have a flat top and a flat bottom and flat sides. That tells you that the block is complete complete and will resolve properly. So in this case, I might slide this touchscreen control inside of our function. Do note that when blocks get close to each other and they are compatible, you'll see that little amber icon light up saying, hey, this is good. I want to connect here. And when you release, they will snap to each other.
Nom, 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 nom.
Exactly like that. So the crocodile has now eaten my touchscreen, right? But I've got a flat top, a flat side, flat bottom. That means that this code is completely functional on its own. It runs this line of code, and then if I had more lines of code, it would proceed down and do each of these until it's complete. Now, there are other blocks that require some kind of input in order for them to be able to be resolved. For instance, if I grabbed a string block here, here's one that says create string with, and it's got 2 inputs. This does not have a flat side. It's got a flat top and a bottom, but this needs to be inserted into something else. It needs to be used. Its information will be fed into another block in order to make that block complete. For instance, maybe I'll grab this system debug print. Slide that in here, and you can see that it is not complete until it gets something in that hole. So we connect our string block to that, and then maybe I'm putting other strings in here, right? Maybe this is a string there, and this is another string there. Once these are all connected, this entire block is resolvable, right? All 4 sides are smooth. That means that it's not waiting for any inputs, and it's ready to move on to the next line. It can't go on to the next line until it's complete itself. So you're always trying to keep an eye on that, making sure that your blocks are complete before they move on, Now, one thing that's kind of worth noting is that some of these blocks, like this one here, when you connect it, they're on the side like that, but some blocks you can right-click and change the way that it brings in those inputs. Right now it's using what's called external inputs. I could change that to be inline inputs, in which case the block becomes much longer, but these inputs now exist as windows inside the block. Like if I pull these out of here, you'll see that these are just open holes. So same mentality here. You got to fill the holes. This block is not resolvable until the holes are filled. This is purely a cosmetic change. So I could choose to have my inputs be inline, which makes them a long line, makes it a long horizontal block. Or I can right-click and go back to external inputs, in which case they are outside of the block and they need to be fed, and they're on top of each other. Now, this is just for you. This is really, there's no change in the code whatsoever. Sometimes this is really, really helpful so that you can see different things on top of each other in a list, like in an order, rather than having them be really long and wide and in a block that may be too long to look at. So just be aware of that. Internal inputs versus external inputs can be really, really useful for helping your code get cleaned up and look more natural, especially when you're doing things like AND blocks and OR blocks where you want to compare things. I find it more useful to have those on top of each other rather than side by side. Also worth noting that when you break blocks, when you pull a block out of another sequence of blocks, everything below the block that you grab will come with it. So if I grab this touchscreen block and pull it out of here, the debug print comes along for the ride. If I wanted to just grab the debug, I could pull that one off, and it will not take anything that's above it. So just be aware of that as you start breaking blocks apart. If you're like, oh, I want to pull this touchscreen out of here, but I don't want to grab the bottom one, you can't really do that. You got to pull them both and then take the thing beneath it and put it back in there to reconnect it. So that's the sticky nature of these blocks. Everything beneath it, it assumes you want to take with it. And then something else you saw really briefly, something called a ghost block. When I grabbed that debug print, I pulled it in here, it had this sort of softly colored string block in here. You'll notice it looks different than this string block we grabbed from the actual inventory itself. This one is a dark blue, that one is a light blue. What's the difference? Well, whenever you bring in one of these blocks that has a ghost block attached to it, what it's basically telling you is that it is expecting a string to be in that slot. There's a lot of ways that you could provide a string to a block. You could provide it with this string block right here, like I just did. But maybe another way you could do it is maybe you've got a variable in your system somewhere, and that variable is a string. And you could connect that variable in here. And If that variable is a string, then it will successfully give that line of code what it needs to resolve. But what it's telling you is that no matter what, it's expecting something that will eventually be a string. Same thing is true for, you might have a true-false ghost block. There's lots of things that might resolve down to the word true or false that you could connect into that open spot, but it's just telling you, hey, this is what I'm looking for. And if all you need is just this string, like I don't need anything else, I can just type in here, this is valid code. Oop, that works fine. You can type directly into a ghost block and it will function fine. There's nothing wrong with that. The only thing that it can't do is it can't be copied and pasted. So like I can't grab this block and break it off of the debug print now. So I can't duplicate it and put it somewhere else the way I could if it was an actual string block, right? This is valid code. With this one, I can remove that, or I could copy and paste it, put it somewhere else. So for that reason, you might see me instinctively replace all of my ghost blocks with an actual block that represents that data, but you don't have to. If that ghost block gives you the data type that you need and you don't need to go any further than that, it's fine. Leave the ghost block where it is. Okay, so I'm going to delete all this. That shows you most of the behavior of all of the blocks that you'll experience. We'll see all the nuances along the way. Let's take a quick break, and then in the next section, we'll start getting our blocks to do what they need to do.